Good morning, good morning, good morning. Can you hear me? Thank you so much. Okay, I just like to believe that everybody is settled and we are happy and ready to face the few days ahead of us. Colleagues from the Faculty of Science and Agriculture, other members from the sectors of the university that are here, and also the invited guests, I would like to express my sincere greetings to all of you, and this is on behalf of the Faculty of Science and Agriculture. Standing here is Chipiwa Mandiwana Neudhani, and I am representing the faculty in my capacity as the Faculty Higher Degrees Committee Chairperson and also the Chairperson of the Organizing Committee. So today is the 17th of September, right through the 20th of September. This is where the Faculty of Science and Agriculture researchers, be it the staff, the students, will be making it happen. So in other words, including our invited guests, they will be sharing the research, the findings, the knowledge, and the wisdom they have. It's a different year, different dates, and of course, we have a different theme. And this year, in the 14th Faculty of Science and Agriculture Postgraduate Research Day, the Faculty Higher Degrees Committee has organized this event under the theme that I am going to read here. Advancing Science Through Research, Addressing the Challenges of Climate Change in an Era of Artificial Intelligence. Ladies and gentlemen, I'm just going to change the gear to slightly get to a moment where I recognize the management that is here, and starting with is the DVC, Research, Innovation and Partnership, and that is Professor T.M. Mutiba. And without any waste of time, I really cannot sit down without acknowledging the presence as well of our Executive Dean, Professor Hlengani J. Siweya. Professor Siweya, the faculty really would want to thank you for your unwavering support. Your vision of actually giving each and every student an opportunity to present their research is really appreciated by the faculty, because that is to ensure them that they also realize the dreams through this event. So we're now going to move to acknowledging the presence of our invited guests, just like that, without mentioning any names, the sponsors of this event, the Faculty Executive Committee, and like I said, I'm not going to single out any name because of time. So we're now going to welcome to the podium the DVC, Research, Innovation and Partnership, Professor Mutiba, to come to the podium and welcome the conference delegates. Thank you, Prof. Mutiba. You can come home.
Vice Chancellor and Principal of the University of Limpopo, Prof. Mahlo Mokhalong in absentia, DVC Teaching and Learning, Professor Madaje in absentia, executive deans of faculty, directors of school, HODs, senior and junior researchers in attendance, students, good morning. Good morning. On behalf of the executive management of the University of Limpopo, it is an honor and humbling privilege for me to welcome you all to this 14th Postgraduate Research Day seminar of the faculty in the sunshine, where history is made in front of our eyes. Clap hands. That is Faculty of Science and Agriculture. You seem not to be knowing your slogan. I specifically want to welcome all keynote speakers, that is Dr. Mary Jane Murunwa Bopape from South African Environmental Observation Network, Prof. Zandile Mutha from University of Eswatini at Eswatini, Dr. Sophie Ranga from University of Johannesburg. I also want to welcome plenary speakers, poster presenters, and all conference delegates. As you can see, the program for the Research Day seminar is amazingly rich in content, and your participation demonstrates the significance of this Research Day seminar to our strategic goal of research engagement, dissemination, and output. For those visiting Limpopo Province for the first time, we as executive management of the University of Limpopo, we warmly welcome you. The theme of this 14th Postgraduate Research Day seminar is Advancing Science Through Research, Addressing the Challenges of Climate Change in an Era of Artificial Intelligence. This research themes aligns with Sustainable Development Goal 13, which advocates for immediate action to combat climate change and its effects. We hope that the presentations and discussions over these 3 days will generate robust, thought-provoking scientific ideas on the dynamics and challenging nature of climate change, utilizing artificial intelligence as a technological tool to mitigate the challenges associated with it. Science, particularly good science, is a powerful tool for advancing society. There is no doubt that what the society is today and will be tomorrow is the result of good scientific research. As a rural community serving institution, our research should be designed to address local community challenges. This has been our university's guiding principle in addressing or finding answers to African problems. As a result, our studies should be designed and problematized to address the needs or the concerns of our immediate community and beyond. As you are aware, colleagues, the challenges of climate change is accompanied by food insecurity, diseases, environmental pollution and degradation, poverty, crime, and other issues. I will invite all our partners and sponsors and also funders to embrace these challenges of finding solutions to the climate change affecting our communities in order to live an improved and sustainable lives. These can be accomplished through collaboratory finance studies on science development that employs artificial intelligence to navigate the issues of climate change that our society is currently facing. The Faculty of Science and Agriculture, where history is made in front of our eyes, we know very well that this faculty is the university's research flagship faculty, consisting of high-level, experienced, and well-respected research academics and scientists, both locally and internationally. As a result, you have no cause to worry about providing them with research funding chances to investigate climate change challenges through the lens of scientific endeavor, using artificial intelligence for optimal and long-term solution. This is the strong message I'm sending to sponsors and funders. Ladies and gentlemen, I believe that it is our shared obligation to confront the difficulties posed by climate change through scientific research. The phrase which says, "We can't manage what we don't measure." This is perfectly capturing the world's ever-changing conditions, which encompass multiple planetary crises such as climate change, nature and diversity loss, pollution and waste. As academic scientists, we should utilize the massive climate data at our disposal in a scientific manner to address the challenges. The use of AI is one effective approach for accomplishing this. To put it simply, artificial intelligence refers to systems or machines that do tasks that normally require human-level intelligence. The theme of this postgraduate day seminar encourages academics, postgraduate students, and other stakeholders to research or pursue potential solution of applying artificial intelligence to address environmental issues to improve human lives. As postgraduate students of Faculty of Science and Agriculture, this Research Day seminar provides an opportunity for you to present your research, receive constructive feedback, engage with your supervisors and peers outside the institutional setting, and network with other attendees of this research event. I urge you to discuss and interact freely with your supervisors about your research proposals, data collection procedures, data analysis, and write-up. Ultimately, I encourage you to seek assistance from your supervisors to publish your findings in peer-reviewed accredited DHET journals. By doing so, you will advance knowledge and promote our university standing on the local and international map. Similarly, I passionately urge academic staff to encourage and motivate their students to publish their research findings and to disseminate these findings to our stakeholders and communities in order to inform policy and practice. Sharing and utilizing the knowledge gained from research studies help to narrow the gap between research, practice, and policy. I thank the organizing committee of this Postgraduate Research Day seminar for providing a platform for academics, scientists, researchers, and students within and beyond South Africa to present their research findings related to the application of science research in tackling climate challenges in the era of artificial intelligence. Similarly, I extend my gratitude to the faculty leadership, which includes the Executive Dean, Professor Hlengani Siweya, school directors, HOD, and all academics, and the research professor for their efforts in organizing this 14th Postgraduate Day seminar. As the University of Limpopo Executive Management, we thank the organizing committee, presenters, and sponsors for their contribution to the event's success. Once again, I warmly welcome you all to this 14th Postgraduate Research Day seminar. I wish you a resourceful and enriching Research Day event. Thank you all and enjoy your 3 days.
Thank you, DVC. There is only one special announcement that I would like to make. The DVC would really love to be with us for the entire day, but unfortunately, she has to go to the other venue where the Faculty of Health Sciences are also having their research day. So she will be leaving this room. Thank you so much, Prof. Enjoy the day at the other venue. Thank you. Can we please clap hands for her as she leaves? Okay, I've got an announcement to make here. The acknowledgement of the arrival of Professor Lesivana Rafapa, the research professor in the Faculty of Humanities. You're welcome. Thank you. Okay, let's now move to the keynote address that we are going to have this morning. And we have the speaker, who is our national speaker. I'm saying that because we also have an international speaker in line with the as far as the keynote speaker is concerned. So in our midst, we've got Dr. Mary Jane Bupape, and what I'm going to do now is to quickly go through her short bio, and then after that, she will then have to come to the podium and present a lecture. So Dr. Mary Jane Bupape is the Managing Director of the South African Environmental Observation Network, SAEON, a business unit of the National Research Foundation. She holds a PhD in meteorology from the University of Pretoria, and she was a postdoctoral fellow at the University of Reading in the UK. Her expertise extends to the use of numerical weather prediction modeling at the South African Weather Service, climate change projection at the CSIR, and she also has worked at CHPC, supporting earth scientists during using high-performance computing systems. She has led a weather and climate project for the SADC Cyber Infrastructure Framework. Dr. Bupape co-authored 40 peer-reviewed papers, several conference proceedings, and co-supervises postgraduate students at multiple universities. She has received several awards and serves on various scientific advisory roles. So Dr. Bupape will be giving an address under the topic, Harnessing Artificial Intelligence to Address Climate Change, Enhancing Observations, Models, and Early Warning Systems in South Africa. Can we please give her a round of applause as she comes forward? She's just going to come and assist.
Okay, good morning, everyone. Thank you, Professor Mandiwane Neudani. Good morning. I think the Executive Dean is outside a little bit now, Professor Siweya, and the DVC in absentia a little bit. I think I was actually looking forward to standing here and being able to say Tovela, because I come from this area. I've spent now most of my life in Pretoria, but the first 16 years of my life were spent right here in Limpopo. So I woke up this morning in my mother's house at Unit C, and I matriculated at the Huiti High School. So I was really happy to receive this invitation so that I can come and speak to my people. So today I'll be talking about weather and climate, and I'll be speaking to observations just in terms of what we have. I'll talk to models across all time scales, and I will also be talking to early warning systems. So I hope by the end of my presentation you'll have some good idea of how weather forecasting works and what challenges are in place, and those of you maybe still thinking about topics for your PhDs or thinking about doing some postdocs, maybe might have some ideas on what to do next. I think, first of all, I work in a national facility of the National Research Foundation, but the national facilities themselves have a sort of, they've got their own logos, which is why sometimes it's said I'm from Sion, but the business entity itself is NRF. And I'm sure a lot of you know of the NRF because it's known more for giving bursaries to postgraduate students, and we also give funding for research proposals. But the NRF also hosts 5 national facilities. 2 of them are in the astronomy space. We've got one in radio astronomy, and we've got one in optical astronomy. We've got a national facility that works on nuclear sciences, and we have 2 national facilities that work within the environment discipline. We've got SIAB that focuses on marine biology, and we've got the South African Environmental Observation Network, which is where I work. And as I present, you will get to see some of the work that we are doing there. Within Sion, we've got 7 nodes, and where you see those dots there, that is where we've got our offices. I heard in the opening the DVC mentioning that you would like to deal with issues at the local level, and we are placed in these different offices across the country so that we are able to engage with the communities that live in these areas. We were established in 2002 within the NRF, started off just with 1 employee, and at the moment we've got just over 130 employees. We've got 4 nodes that focus on terrestrial sciences. We have 2 nodes that focus on marine sciences. We have 1 node that focuses on, it is basically our ICT and data node. So it's responsible for our data platforms where scientists and postgraduate students can go and download data sets that we collect. We also host 3 research infrastructures, and I'll speak to these a little bit as I proceed. I think, first of all, I mean, we are funded by government. So as the NRF, we are under the Department of Science, Technology and Innovation, and the majority of our funding comes from National Treasury through that department, and all the observations that we are putting up, even our salaries are paid for by the government. And we know as a country that there are competing priorities, there are issues we are tackling with, we are dealing with as a country. And the question would be, why should we be investing in environmental sciences? And this slide that I'm showing you here shows what the experts across the globe say are global risks that we are dealing with. So I'm showing what came out since 2021. So the report that came out in 2021, in 2022, 2023, and the last one, which was published in January of this year. So everything that you see in green there are all the environmental challenges that we are dealing with. And you can see that according to the experts across the globe, environmental challenges are really coming out as the top risks that we are dealing with as the society. With this latest one of 2024, you can see extreme weather is coming up right at the top. As you know, the challenge that we'll be dealing with in the next 10 years, and I'm sure you've seen in our headlines that we are really struggling in South Africa as well with some flooding that occurred because of heavy rain that have occurred. Critical change to earth systems is coming up as second. Biodiversity loss and ecosystem collapse and natural resource shortages. I'm not going to read everything, but really the message there is that environmental challenges, so environmental sciences as a discipline is really an area that we need to deal with and really get to understand to deal with societal challenges. In South Africa, we are located in what is called the subtropics. So we've got the tropics, we've got the subtropics, we have the mid-latitudes, and then as we go further south, we get to the polar regions. And the weather that we experience is informed by where we are located. We've got oceans surrounding us, we've got the Atlantic west of us, we've got the Indian Ocean, and then there's the Southern Ocean far south of us. And the oceans that surround us also have an impact on the weather and climate that we experience. The subtropics are characterized by high pressure. So if you've got high pressure over land, we get subsidence. So instead of the air ascending, which would cause rainfall, if you've got a high pressure system, the air will be descending, leading to dry conditions. And that in itself means that as a country, we are generally a dry country. But when we get some disturbances that come from the tropics, or we get disturbances coming south of us from the mid-latitudes, that is when we get some rainfall. Sometimes the subtropical systems, so we've got the semi-permanent Atlantic high pressure system. We also have the semi-permanent Indian Ocean system. Sometimes when they interact with some of these mid-latitude systems, they can result in really heavy rainfall. When we had those devastating KwaZulu-Natal floods, there was a mid-latitude system which was interacting with a a raging high pressure system. So it was a subtropical system sort of interacting with a mid-latitude system that resulted in that flooding. I'm showing you in that figure there the teleconnections. So we've got what we call the El Nino Southern Oscillation. So for seasonal forecasting, this is really the driver. When sea surface temperatures are above average in the equatorial Pacific, South Africa tends to receive below normal rainfall. That is when we've got El Nino. And when the sea surface temperatures are below average, that's when we've got La Nina, and we say generally South Africa experiences above normal rainfall. So these are the types of things that would inform what goes into our forecasts. We are not spared from the disasters. This, what I'm showing you here is an analysis that is based on the emergency database. So this is an international database that records disasters across the globe. There is a definite underestimation of disasters occurring over the African continent. For example, there's hardly any heat waves that are being reported. If you compare the number of reports for Europe and for us in South Africa, you'll find there's a big discrepancy. What we found looking at data from 1980 up until 2023 was that there was only one heat wave that was reported for South Africa, but that's really because to report these disasters is very difficult. They've got 4 things that they would like to see in order to record an event as a disaster. There needs to be at least 10 people that pass away because of the event. There has to be at least 100 people that get affected by the event. There has to be a declaration of a state of emergency, or there has to be a call for international assistance, and that is how an event makes it into this database. That histogram you see there shows you how many and the type of disasters that we found reported from this database, and you can see that similar to the rest of the globe, floods dominate in South Africa as the leading cause of natural disasters. So we've got floods, we have storms. Storms themselves can also be associated with flooding because included there are also tropical cyclones that are associated with a lot of rainfall as well as high wind speed. So we also wanted to ask which areas in South Africa report the most disasters, and you can see, so in terms of the floods, it really seemed like in Limpopo there haven't really been many that have been reported. With KZN, we've seen it making headlines a lot of times, and you can actually see eThekwini almost jumping out of the page in terms of the number of floods there. And also when you look at the number of storms, you can see that eThekwini is the one that is really leading there. You can see some different, I mean, in terms of the metros, South Africa has eight metros, and there are 4 of them that are sort of jumping out. eThekwini being the leader, we've got Cape Town, and then you've got Johannesburg as well as eThekwini that are sort of coming out. eThekwini reports more storm disasters compared to Johannesburg, while Johannesburg reports more flooding events. So, I mean, when we talk about artificial intelligence and where it can come in, it's really assisting us in the development of early warning systems. So there are a lot of reports that keep coming out that indicate the impact that these extreme events have on livelihoods. People lose their lives, people get displaced, their houses get damaged, droughts, which are more a climate feature, can lead to malnutrition when the food is not there, and there are a lot of economic damages that can occur with that. So the economies of the countries can also be impacted. So when we talk about early warning systems, there are just some requirements that are needed there. What you see on the left, my left, you can see there are 4 pillars that the World Meteorological Organization, or rather the UN, has come up with as what is needed in order for us to have proper early warning systems. So in 2022, the UN declared that by 2027, every person on Earth should have access to early warning systems. And the World Meteorological Organization then went and said, what are the pillars that we need to be dealing with? And they also costed these pillars. So I'll be speaking more to that pillar too. So I mean, first you need to understand what you're exposed to, what your vulnerabilities are. So that is pillar 1, which speaks to disaster risk knowledge. And then pillar 2 is observations and forecasting. Pillar 3 is dissemination and communication. So you can have your perfect forecast. If the people that need to respond to it do not receive it, then it becomes really a useless forecast. So that is why that pillar is also important. And after you receive the forecast, or after you receive your warning, you need to be able to respond. And that is why we also have that pillar 4 there. So in terms of forecasting, I hope you all know the difference between weather and climate. But that figure that I'm showing you there really shows you actually that difference. So within forecasting, we've got different time scales that we deal with. We've got what we call nowcasting, which refers to what is happening right now, up until about 2 hours ahead. And then in terms of numerical weather prediction in general, we really tend to look at what the models show from about 6 hours up to about 3 days. So that is really where numerical weather prediction would come in. And the models can run, and we can get some useful information going up to about 2 weeks. And then beyond the 2 weeks, there's really not much. Like if you can continue running your model, it can show you something. But the value of the information you get from there really starts reducing because of the uncertainty that is there. Then we also, with seasonal forecasting, I've already mentioned ENSO. So in the way that it started because we were able to see some memory that got left in the atmosphere because of the sea surface temperatures. So I talked about the sea surface temperatures in the equatorial Pacific Ocean having an impact on our rainfall here in South Africa. So with seasonal forecasting, that is really what we are talking about. So those of you that are doing maths, so we'll think of seasonal forecasting as more of a boundary, where it's a boundary value problem. And then as we extend with climate change projections, in the way that we run our models, there'll be projections that will inform these models, and then we run these models, and then they will react, the climate will react based on the concentration of greenhouse gases that are inserted into these models. This here shows you the observation network that we have in South Africa. There are different types that you can see there in the legend. It is showing observations from the South African Weather Service, which has got the most observations, not particularly in terms of automatic weather stations. We've got the Agricultural Research Council. They also have some observation network. And then we also have SCION, which is where I work, where we also have some observations. And you can see that you've got a lot of black dots. Those are manual rainfall stations, and there is a table there which shows the temporal resolution that is associated with these different observations that we have got. So with the manual stations, somebody needs to go out and then read on the rain gauge how much rainfall was received, and therefore we are only able to do that once a day, which is why generally we will take that observation at 8 a.m. In the morning here in South Africa. But when it comes to the automatic weather stations as well as automatic rainfall stations, we can get higher temporal resolution because you don't need somebody to go out there to read up the observations. In fact, as the stations are there observing, be sitting in my office in Pretoria and be able to see what the observations are. As they're observing, they can be communicated so that we receive the information and know what's happening in terms of real time. So as South Africa, in terms of the observations, we are impressive if you were to compare us with the rest of the continent, but we don't have enough observations. If you engage with all these organizations, they'll tell you that they are struggling in terms of their budgets to maintain these stations. This one here, I put the source slide because this is the weather radar network of source, and I thought it's important to include it just to show the differences in terms of the infrastructure that we require for different time scales. So a weather radar is a system that is critical for nowcasting purposes. So what I said in terms of going from 0 up to 2 hours. So there, the system that you really want to get well is a thunderstorm. And what a weather radar does is that it sends out a beam, and then it